Hello students, this is Mr. Wilsey, and in this video we are going to multiply and factor out monomials. So I need you to get out paper, and I need you to take out notes with me. It does not need to be grid paper, it can be lined paper, that's fine. Now remember that a monomial looks something like this, for example. So example 1. 2x. That is a monomial. It is one term. It is one thing. Now let's multiply this monomial by, let's say, a binomial. 3x plus 1. Now in order to indicate that we're multiplying this monomial by that binomial, we need to put the binomial in parentheses, like that. Okay, 2x times, in parentheses, 3x plus 1. Now in order to multiply this monomial, we need to distribute the 2x into the parentheses. You know that. So 2x times 3x plus 2x times 1. Now let's simplify this. This is what you were doing in the last chapter. So here we multiply the 2 and the 3 to get 6, and then multiply x times x. We add the exponents. In this case, the exponent on each one is 1. So 1 plus 1 gives 2. X squared. Okay? 2x times 3x is 6x squared. And then 2x times 1 is just 2x. Okay? So that was a piece of cake. Let's look at a slightly more challenging example. What about, what if our monomial was negative x cubed? And we wanted to multiply that monomial by this trinomial, 9x to the 4th minus 2x cubed plus 7. Okay? So in order to multiply these two, we need to wrap the trinomial in parentheses, have the multiplication sign here. Okay? Again, just like in the first example, we need to distribute the monomial to each term inside the parentheses. So negative x cubed times 9x to the 4th plus negative x cubed times negative 2x cubed plus negative x cubed times 7. Okay? And then let's simplify this. Negative x cubed times 9x to the 4th. Now this is going to be negative 9 times x to what exponent? Well, we add the exponents here because we have the same base, x, being multiplied. 3 plus 4 gives 7. That is the exponent on the x. Now let's look over here. Here we have a negative multiplied by a negative, so the result is going to be positive. There's an invisible negative 1 here, times the negative 2 gives a positive 2. Now x cubed times x cubed, add the exponents to get 6. So 2 times x to the 6th power. Now let's look over here. We have a negative times a positive, so the result is going to be negative. There's going to be a negative 7, and then x cubed, because there is no x over here. Okay, so that is the result of multiplying. Alright, now let's talk about factoring. Now, you've seen this word factor before, probably in this expression, greatest common factor, or GCF. You've probably done this a lot in middle school. So let me give you an example of a middle school type of problem. Example 3. Let's say we wanted to find the greatest common factor of 18 and 24. Now, this is what we would do. 18. Let's break this down into its prime factors. Okay? Let's have a thought bubble up here. In order to find the greatest common factor of two things, we need to break the things down into prime factors. Now remember what the word prime means? Well, we'll see in just a second, okay? So 18. What two numbers can we multiply to get 18? Well, how about 2 and 9? 2 times 9 gives 18. Now, what two numbers can we multiply to get 2? Well, the only possibility is 1 times 2. The only factors of 2 are 1 and itself. That means it's prime. How about 9? Is 9 a prime number? Well, no. There are other factors of 9 other than 1 and 9. How about 3? If I multiply 3 times 3, I get 9. Now, let's look at the 3's. Is 3 a prime number? Yes, it is. The only possible numbers that I can multiply to get 3 are 1 and itself, 3. This means that I have successfully broken down 18 into its prime factors, 2, 3, and 3. Now, what this factor tree, okay, kind of looks like a tree. What this factor tree tells us is that 18 is equal to 2 times 3 times 3. Okay? So the prime factorization of 18 is 2 times 3 times 3. Now let's do the same exact thing for 24. Okay? Now, so the first step to breaking 24 into its prime factors is to draw two lines beneath it and ask ourselves, what two numbers can I multiply to get 24? Any two numbers that I can multiply to get 24. How about 4 and 6? 4 times 6 gives 24. Now, let's look at the 4. What two numbers can I multiply to get 4? Well, how about 2 and 2? Now let's look at the 2's. The 2's cannot be broken down any further because they are prime. So let's circle them. Circled, circled. Bam. We have reached the end of the tree in that direction. Now let's look at the 6. Can I break down 6 into any prime numbers? Yeah, how about 2 and 3? 2 times 3 will give the 6. And as we saw over here, 2 and 3 are both prime. Prime, end of the line. Okay? So the numbers that I circled here are the prime factors of 24. That means that 24 can be written as 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. Now, let's answer the question that we posed up here. What is the greatest common factor of 18 and 24? In order to find the greatest common factor, we look at these two prime factorizations and we circle the things that the two numbers have in common, that the two factorizations have in common. Well, they both have a 2 in common, so let's circle the 2 up here, circle the 2 up here. And what I'm going to do is I'm going to draw a line between them. Okay? Now, is there anything else in common? Well, yeah, both of these have a 3. There's 3 here, there's a 3 here. So I'm going to connect them with a line. Now, there's a 3 that's left over up here, and there's a 2 times 2 that's a leftover down here. But we can't match them up. So that means that just the 2 and the 3 are common factors. And since we've circled all of the common factors, we have found the greatest common factor of 18 and 24. The greatest common factor is 2 times 3, which is 6. Okay, so we have found the GCF. It's 6. Does this kind of sound a little bit familiar from middle school? Now, let's bump this up a little bit in complexity. Okay. Now what I'm going to want to do is, in example 4, find the greatest common factor of, let's say, 28x cubed and 70x. Now notice the difference between this example and the previous one. In this example, our numbers are bigger, but also we have x's involved. So let's see how that is going to complicate things. First of all, let's focus on just the numbers here, because for middle school you know how to find the GCF of these numbers. Okay? So let's first of all look at the 28. 28. What two numbers can I multiply to get 28? Well, how about 2 and 14? Okay, 2 is prime, so we circle it. That's the end of the line there. How about 14? What two numbers can I multiply to get 14? Well, how about 2 and 7? 2 is prime. How about 7? What two numbers can I multiply to get 7? Well, the only possibility is 1 and 7, which means 7 is prime, so I circle it. Now let's write out the prime factorization of 28. (28) is equal to 2 times 2 times 7. Now remember that we had an x cubed. X could be anything. We don't know its value. Okay, so the way that we're going to include the x cubed in our prime factorization, I'm going to write the x cubed here. Remember that x cubed is just the same thing as times x times x times x. 3 x's multiplied together. Okay? So all I've written is that 20x cubed is equal to 2 times 7 times x times x times x. I'm just breaking it down into its simplest pieces. Now let's do the same exact thing for 70. Okay? I'm leaving off the x for now, but remember that our goal is to find the prime factorization of 70x. What is 70x equal to? Okay? So let's first of all do the prime factorization of 70. What two numbers multiply to give 70? Well, the first thing that comes to my mind is 7 and 10. 7, like we saw over here, is prime, so we circle it. How about 10? What two numbers multiply to give 10? How about 2 and 5? 2 is prime, and 5 is also prime. Okay? So the prime factors of 70 are 7, 2, and 5. Now I'm going to write these in order from lowest to greatest. So 70x is equal to 2 times 5 times 7. And then of course we have an x here, so times x. There we go. So we have found the prime factorization of the two terms that we're interested in. Now just like in the last problem, here, we are going to circle the things that the two terms have in common. So up here we have a 2 in common, so I'm going to circle them in both factorizations and connect them with a line. Then they both have a 7 in common. Now they both also have 1x in common. So I'm going to circle one x and link it up with the other x. Now we have some leftover stuff that I didn't circle up here, and a leftover thing down here as well. But if I want to find just the greatest common factor, all I have to do is take the stuff I circled, multiply it together. 2 times 7 times x. And then I'm going to simplify that back into 2 times 7 is 14x. That is the GCF of 28x cubed and 70x. Alright, now let's make this even more complicated. We're going to look at an example 5. Now, let's say the directions to this problem are factor 5x cubed plus 25x squared plus 45x. Now, that is a one-word direction, factor. All it means is, in this case, step 1, find the GCF is the first step, and then the second step, we'll talk about that when we get there, okay? So first of all, let's find the GCF of these three terms, okay? And at this point in time, I hope that you don't have to write a factor tree for everything. If you want to, that's all right, but let's try to write it out like this. 5x cubed, and then 25x squared is the next term, and then 45x is the third term. Now, we're going to try to find what the prime factorizations of these three terms are. Now, 5 is prime, as we've seen. 5 is prime. So 5 is in the prime factorization, and then we have 3 x's multiplied together. So 5x cubed, the prime factorization of that is 5 times x times x times x. That's as simple as we can write the factors of that term. Now how about 25x squared? Can you do 25 in your head? Find the prime factors of 25 in your head? I hope that you recognize that the prime factors of 25 are 5 and 5, right? 5 times 5 will give the 25. And then x times x will give the x squared. Okay? So that's the simplest way to write the factors of 25x squared. Now how about 45x? Well, I don't know about you, but I can't think of the prime factors of 45 off the top of my head, so I'm going to come back up here and write a factor tree, okay, for 45, and just 45, because it's more complicated than these two. So what two numbers multiply to give 45? Well, I know that 5 and 9, right? 5 is prime, so circle it. Now how about 9? Well, 9 can be broken into 3 and 3. Bam, done. Primes. So 45 is equal to, again, I'm going to write this in order from least to greatest, 3 times 3 times 5 times x. Okay? Now, the first step here, again, is to find the GCF of those three terms. So we're going to do exactly what we did up here, except this time, we need to find what is common among all three of these prime factorizations. Okay? What appears in all three of them? Well, first thing I can see is that a 5 appears in all three of them. There's a 5 here, there's a 5 here, there's a 5 here. So I'm going to connect all three of those with a line. What else is in common? Well, there's an x in common. So I'm going to circle the x, circle the x, circle the x, connect them with a line. Okay? That is all that is in common among all three of these. So the so the greatest common factor of those three terms is 5x. Now, this is just the first step of this problem. The next step is to find what is left over. Now, what do I mean by that? Well, what did I not circle in each of these factorizations? Well, I didn't circle x times x up here So the leftover part is x times x, which is x squared. Now what did I not circle in the second row? I didn't circle 5 and x. So the leftover part is 5x. And I didn't circle 3 times 3 down here. So the leftover is 3 times 3, which is 9. Okay? Now, watch what we're going to do. The GCF of this is 5x. The leftover pieces are x squared, 5x, and 9. So a way that we can write this expression is x squared plus 5x plus 9 in parentheses times 5x. Now notice that this looks very similar to what we were doing in the first examples here. We had a monomial multiplied by, in this case, a trinomial. So what we were doing in the first examples was multiplying. What we're doing now is factoring. And the result of factoring, and this, by the way, is the final answer, the result of factoring is the exact opposite of the result of multiplying. Okay? Let me write that out for you. Factoring is the opposite of multiplying. Okay? In this example, we started with a trinomial that looked like the final answer in this example. And when we are asked to factor this, we end up with something that looks like what we started with in this example. Okay? Factoring is the opposite of multiplying. Alright, now I'm going to do one last example for you, because this can be kind of a challenging skill, just because it's probably brand new to you. So, example 6. I'm going to go through this quickly. Factor 24x to the 5th power minus 4x to the 4th power plus 8x squared. Alright. Now remember that the first step is to find the GCF of all of the terms. So I'm going to write out all of the terms in rows. So 24x to the 5th equals what? I'm going to find the prime factorization of that. Negative 4x to the 4th equals what? And then 8x squared equals what? Okay? Now, let's find the prime factorizations of these. Let's start with 24. 24. Let's come up here, because I can't think of the factors of 24 off the top of my head, so I'm going to come over here and make a factor tree. 24 is equal to 2 times 12. 2 is prime, circle it. 2 is equal to 2 times 6, 2 is prime. And 6 is equal to 2 times 3. I'm going to circle those. Okay? So 24 is equal to 2 times 2 times 2 times 3. And then we have 5 x's multiplied together. Okay? So we found the prime factorization of 24x to the 5th. Now let's find the prime factorization of negative 4x to the 4th. Now here, this guy is negative. So one of the factors we're going to say is negative 1. Okay, let's just get that negative sign out of the way. Negative 1 times what? Well, negative 1 times the prime factors of 4 are 2 and 2. Okay, negative 1 times 2 gives negative 4. And then I have 4 x's multiplied together. Now 8x squared, let's see, 8 is equal to 2 times 4. So 2 times 2 times 2. Okay, so 2 times 2 times 2 gives the 8, and then I have 2 x's multiplied together. Bada bing, fantastic. So now that I have all of the prime factorizations, the next step is to identify what is in common among all three factorizations. Let's see, I have a 2 in common. So link those up. Ooh, I have another 2 in common. A different 2. And then link those up. Now I have a 2 up here and a 2 down here, but I don't have a 2 in the middle anymore, so can't circle those. How many x's do I have in common? Well, I have an x here. Link those up. And then I have another x here. And it looks like that's all of the x's that I can circle. So the GCF, the greatest common factor, is the things that I circled. 2 times 2 times x, which, when simplified, is 4x squared. Okay? Now remember that step 2 is find what is left over. What did I not circle? So, leftover parts. So leftover parts of 24x to the 5th is 2 times 3 is 6. X cubed is left over up there. Negative 1 times x squared, so negative x squared, invisible 1 goes away. The negative sign does not. And then left over down here is 2. Okay? So, I have my GCF, and I have my leftover pieces. That means that the final answer, so write the factored expression, would be the final step. So the way to write this answer is the GCF, 4x squared, times, in parentheses, the leftover stuff added together. 6x cubed plus a negative x squared plus 2. There we go. We're done. We have successfully factored our second trinomial. Hope this video was helpful.